The following question, you're given a reaction in which NaOH is reacting with chlorine to produce NaCl, NaClO3, sodium chlorate 5 and water. What's provided is the concentration and volume of NaOH and the volume of this gas, chlorine gas, 10 dm cube, that's provided, and you're being asked to find the mass of NaCl, the mass of NaClO3 and the mass of water that's produced. Now, starting with the very basic thing, the first thing we're going to try and do is we are going to find the moles of NaOH that are used in the reaction or that are involved in the reaction. So moles of NaOH can be found using the formula moles is concentration multiplied by volume. So it's going to be the concentration given is up to two significant figure, it's 0.45 mole per decimeter cube multiplied by the volume, which is 560.0 cm cube, but it should be in dm cube, so I'm going to divide that by 1000, and the answer that I'm going to get on my calculator is, so it comes out to be 0.252 moles. Remember that one of the values is accurate up to two significant figures, so when you're stating the answer, round it up to two significant figures because your accuracy doesn't exceed that, so it's going to be 0.25 moles. We can then try and find the moles of chlorine gas that are formed using the formula for moles of gases can be found using, you can divide volume of gas that is in the reaction, divide that by the molar volume, which is given up to three significant figure accuracy, 24 decimeter cube, and if I do that, it's going to be 10 decimeter cube divided by 24 decimeter cube, and my moles are going to come out to be equal to, it's coming out to be 0.4166 and the trailing sixes, and again both my values are accurate up to three significant figures, so my answer, it should be accurate up to three significant figure as well, so it's going to be 0.417 moles. So I found the moles of both substances, 0.417 moles, and for NaOH it's coming out to be 0.25 moles. So here I have my final moles. Remember, when you're doing your calculation, use the more accurate values. Remember, I rounded these values because I was stating the answer, but in my calculator, always use the more accurate value, which I've written below. Now I'm going to try and find which one is my limiting reactant and which one is my excess reactant. So the simple thing that I'm going to do is I'm going to multiply on my calculator. I'm going to divide the moles of NaOH by its ratio, which is 6 over here, and I'm going to divide the moles of Cl2 by its ratio in the equation, which is coming out to be 3. So that would be divided by 3, and the bigger of these two numbers would be the one that would be in excess. You can perform the calculation on your calculator. This comes out to be the one on the right comes out to be a bigger number. That means chlorine gas has been added in excess. So what you're going to do is you're not going to use the moles of chlorine gas in any of your calculations further on from this point onwards, because it's in excess. It's not completely taking part in the reaction. The other one is your limiting reactant. You're going to use your limiting reactant moles to find the moles of all the substances in your products. So these moles are not going to be used in your calculations. Now let's start finding the moles of NaCl, NaClO3 and H2O. The ratios are already known. For example, if I want to find the moles of NaCl, it's 6:5. So I'm going to do my working. Let's find the moles. 6:5, which means that 6 NaOH, they produce 5 NaCls. So if you have 0.25 moles or 0.252 moles to be more accurate in my calculations, so 0.252 moles are going to produce how many moles of NaCl, and that would be X. And I can do the same and I can start solving for X. If I use ratios, unitary method, cross multiply, X would come out to be 5 multiplied by 0.252, and it's going to be divided by 6. And the same pretty much would apply to NaCl. I can do the working first. NaCl O3, 6 produce 1, so it's 6:1, and I can then find that 0.25 moles are going to produce how many. So 0.252 ratio x, and again using the unitary method, x over here, the moles would come out to be 0.252, divide that by 6, and you're going to get the moles of NaClO3. And finally we can find the moles of H2O. It's 6 producing 3 water molecules, so it's 6 ratio 3, so it's going to be 0.252 moles ratio x, and again cross multiply x. The moles of over here for H2O are going to come out to be 0.252 multiplied by 3 and divide that by 6. So solving this on my calculator, I get these moles. NaCl, it's 0.21 moles, NaClO3, it's 0.042 moles, and H2O comes out to be 0.126 moles. Now let's try and find the mass, and I'm going to use the formula. Mass is going to be mass is moles multiplied by the MR. So for each one of them over here, I have the moles of all the 3 substances over here, and I'm going to find the mass. So let's try and find the mass now. I've done the working over here, which is the mass is 0.21 moles multiplied by the MR, which is NaCl is 23, Cl is 35.5, so that's given up to 3 significant figure accuracy. NaClO3, you have the moles 0.042, so it's 23, 35.5, and 16. There are 3 oxygens over here, so 16 multiplied by 3, and the other one is mass 0.126 moles, that's given, and multiplied by the MR of water, which is exactly 18. That's 2 hydrogens and 1 oxygen, and if I solve all of them, I'll get the masses. So here on my calculator, I've gotten the final masses. This is for EL, this is for NaCl, 12.285 grams. For NaClO3, it's 4.473 grams, and for H2O, it's 2.268 grams. But remember one thing, that when you're doing your calculation, this concentration was accurate up to 2 significant figures. So all your answers are based on that initial calculation. So all your answers, they cannot exceed an accuracy greater than 2 significant figures. So when you're stating your answers, this value over here is going to be rounded off to 2 significant figures. So it's going to be 12 grams. This answer over here is also going to be rounded off to 2 significant figures. So it's going to be 4.5 grams. And the same is true for this value. It's going to be rounded off to 2 significant figures. So this would come out to be equal to 2.3 grams. And those are going to be your final answers. So remember, when you're doing your calculations, take the most accurate value forward. But whenever you're stating the answer, always state the answers according to the appropriate, according to the least significant figures that are used in the question. So in this case, all your calculations were based on this 0.45 mole per decimeter cube value. So that one value was accurate up to 2 significant figures. So all your values, when you're stating them in your question, they should be rounded off to 2 significant figures. So these would be your final answers for this question.